In question number 2I, we have this rational expression and we need to state non-permissible values and indicate whether they're vertical asymptotes or holes. Find the roots and y-intercept and any horizontal asymptotes. So we're going to first start with the non-permissible values, and the non-permissible values are going to be based on the denominators here and here. Okay, and one of them is going to give us a hole, and one of them will give us a vertical asymptote. So x not equal to -2, this happens to be a vertical asymptote. Okay, I think I left a spot here, so x not equal to -2. So I'm just going to draw in my vertical asymptote at -2. And then I'm going to look at the other restriction, which is x not equal to -3. And in this case, these cancel out. So this is a hole. Okay, so the hole is going to be at x not equal to -3. Okay, so there's our hole. We want to figure out the roots. The roots are going to be based on the numerator. So that I'm going to get a root from there. So my root is then going to be at x equals negative or positive 1/2. Okay, so x equals 1/2 would be the root. I'm going to go ahead and draw that in. So at 1/2, maybe somewhere around there, I'm going to end up with a root. Okay. The y-intercept, we can calculate y-intercepts by plugging in 0. So when I plug in 0, I'm going to get -1/2 in this equation here. Oops, I'll just highlight it. In this equation here, that's going to give me -1/2, but we could also look at that portion over here, and that's going to be -3/6, which is the same as -1/2. So that's going to be the y-intercept as well. So the y-intercept, I'm going to draw, and I'll choose a different color here, in maybe purple, at -1/2, maybe somewhere around here. Whoops. Okay, so -1/2, maybe somewhere around here, there's my y-intercept. Okay, so then I want horizontal asymptotes. So the horizontal asymptotes are what we call endpoint behavior. So the endpoint behavior, let's choose a different color here. Maybe choose a different green here, are going to be what happens as x gets really, really big. As x gets really, really big, the ratio of those two numbers give us our horizontal asymptote. Okay, we could also look at the ratio of those two highest powers. Okay, that's going to give us a ratio of 2, and that means our vertical or horizontal asymptote is going to happen at y equals 2. Y equals 2, and that represents the horizontal asymptote. Okay, we can also say that y is not equal to, since it's a horizontal asymptote. Those are the only details we really need. I now know that this is just going to be a regular rational function. And I really encourage you to draw these so that if you're not sure what these look like, draw them. Become more familiar with these graphs. Okay, the more familiar the more we look at them, the more familiar we are with these graphs, and the better we can predict what these graphs look like. So I'm just going to draw my graph in. I'm just going to follow the asymptotes, go through these holes, go through those points, and get a graph that looks like this. I don't have any coordinates on this in this quadrant, but I can just draw it like that. I don't know for sure that it looks like this, and this is why we want to graph to see what other variations there are. But when you do graph this, it will look like this. This is a fairly simple rational function. Lastly, I just need to make sure I put in the hole. The hole is going to be at x equals -3. So x equals -3 is going to be somewhere around here. at x equals -3, and there's going to be my hole. You may be required to find the y-coordinate of the hole, and to do that, what we do is we plug the x -3 into the simplified equation, so we end up with y equals 2 times -3 minus 1 all over -3 plus 2. Okay, so what we've plugged it into is this portion of the equation, the simplified form, and we get that. So working the y-coordinate of the hole, okay, the y-coordinate of the hole works out to be -7 over -1. That works out to be +7. So this isn't drawn particularly accurately, but that y-coordinate should be at 7. So my scaling is a little bit off. It's probably going to end up more up there when I draw that in. So in fact, I'm going to fix that to make it look a little bit more realistic. Okay, this is not necessary for you to do, but since y equals 7 may be a little bit higher, maybe somewhere up here, okay, the graph really is going to look more like that and follow the asymptotes much further out.